g'day guys. Welcome to, or welcome back to the channel. Now, first of all, the last video, we had Don here from Don's old radio shed. And boy, we had some fun. That was great. Thanks, Don, for the visit. Welcome anytime, mate. It's, yeah, we had lots of fun. It was good doing the radio, but it was good catching up on what we do, as us techs do. And yeah, we had lots of stories and everything, and it was really, really good. So if you want to see Don's channel, there it is down in the corner, Don's old radio shed. Okay, now I did show Don this, and he said, I'm glad it's yours. This thing, we're back onto this. This is a power supply for a portable radio. What this enabled was you to be able to get your battery set, your battery portable or your battery home battery radio, which in 1927 there was a lot of 1-volt tubes around, and be able to run them off power. Now this isn't a portable unit. It requires 240 volts. Basically, it's a power pack for the old valve radios. Now, why do we need a power pack? The batteries run on, well, there was lots of different types of batteries. There was 45 volts, there was 63 volts, and there was 90. I don't think they went any higher than 90. You guys can correct me on this. I'm not real sure about the history of the batteries, but you needed that high voltage for the plates of your valve for the radio to work. So this unit, I haven't really gone in depth in this yet, but we're going to. I would say, being red, that was probably the output. I guess I don't know what this is. We really don't know with it. You've got lots of different voltage selections along the front of it here, which we'll have a look at. And I would say that you selected the voltage you needed for your to eliminate the battery, so that you weren't always operating on a generator and 6 or 12-volt batteries. I think a lot of them were 6 in those days. So there you go. That's what this thing is. A battery eliminator. It's not actually, well, it is a power supply, but it's not a portable one where you can cart the set around with you. This was strictly for the old sets with 1-volt tubes. Okay, it's got a switch on the side, 3-position switch. Have no idea what that's for. In the top of it here, no, there doesn't appear to be anything missing, because I have found, which I'll show you shortly, some information on this, and that's how they work. So I don't know whether this was an upgraded model that had a rheostat under here, but this one doesn't have it. This model did not have that. That's how it came. That's how it was advertised. So let's give you a closer look, and we'll get the top off, have a look, but we'll have to draw this one out because it's sort of a bit of a restore for me bench. We'd like to restore it anyway, just to, yeah, just for something to do. The rectifier in it is, once again, we'll go into this later, is a type BH. And it is a cold cathode rectifier. So I've never, ever seen one of these. I'll give you some details on this shortly. He goes inside, and this fella here, just an indicator lamp, which is a little neon type lamp that sits in here. Now, I would say this lights up when the high voltage is available, because we also have a little indicator lamp here. I have no idea what that one's for. Maybe for low voltage, maybe it has 1 volt for 1.5 for your filaments. I'm not sure, but anyway, let's all have a look. I'll get the top off it here, and we'll try and see what we can do with it. Okay, now there might be a few of you out there that, well, haven't seen the previous video of this. We'll slip the top off, and I'll... How did the top come off? I don't know about slipping it off. Okay, here we go. Nothing under there. Nice black shiny paint, and there's the dial. So probably it says voltage control, but probably was a rheostat in a certain model. As I said, not this one. Okay, in here, a pile of resistors, wiring. Yeah, there's a socket down there for your rectifier. This little light. There's a terminal here that runs across here and over to here. There's a switch that appears to be a voltage select switch. Not sure of how all this is wired up, really. I think the inside does come out of this, but before we undo too many things, I'll probably have to start making some notes on this. Now, this is one big resistor, and I probably rated it, I don't know, 50 watts, maybe 100 watts. These would be 50 watters, I'd reckon. So there's 2 of those joined together, and various taps on this one. It's a not a variable resistor, but you can alter the taps on it. We certainly don't want to do that, so it's going to stay as is. But we do have to get the insides out, and we've probably got to pull this thing totally apart to be able to do anything with it. Okay, up here, very sus looking joint in there. Now I think that could be a capacitor. I don't know. And well, we're certainly not going to plug this in, even with the dim bulb, until we find out a little bit more about this thing and how it used to work. There are 4 feet on this, but they're not more than feet. They're the screws in there. And I would say something comes out here. The bottom comes off, or it slides through the top or something. I'm not real sure. But for it to come out the top, well, we've got to disconnect this fella, take our power cable out, and obviously take the switch out of the side of it. So where do we start? Okay, I'll put the multimeter on some of these resistors now and see, is there anything open circuit up the top here, as well as these fellas? Because yeah, if these are open circuit, we've got a little bit of a problem, but let's check them anyway. This fella will trace the lamp. I've got no idea. These wires go down in here somewhere. I don't know. Okay, let's get the meter and have a look at these. Enough of me rattling on. Don's not here to help me company. Boy, that was good fun. Okay, here we go. Now, first resistor says it's 2800 ohms. Let's see. Well, I'm not going to get much on AC. There we go. 26, 27. Ooh, 28. That's pretty close, isn't it? There's a cap in there, obviously. One of the big caps. Looks like might be still okay. Okay, the next one. From there to the next is 2250. Okay. 22, 22, 22, 23, 24. Pretty close. Okay. Next one is, what have we got here? 3650. That's 3,650 ohm, by the way, not 3,600K or whatever you're thinking there. 3,650 ohm. 3,650. Might be a fraction high, but not very much. Okay, so this resistor is looking pretty good. And to the end, we're looking at 4,000. It's 4K. Okay, come on, 38. Don't let me down on this one. Yeah, about 3880 maybe. Anyway, certainly within spec. Now, these ones up here, I can't actually read them. The numbers are underneath, but what have we got there? Just make sure they're not open circuit, I guess. 4.8, probably 5K. There you go, 5,000 ohm. Let's check this one, which could be the same. And I'd say yes. Yep. Okay, and obviously capacitors in there somewhere. So the wire wounds are all okay, which is a good start. Okay, down in here, we've got brown, black, red. Now that's 1,000 ohms, so 1K. Let's see there. Oh, gee, that's spot on. Okay, we'll get to this other fella, Ray, down in here. He's a 1K as well. 1.1. He's pretty close. Now this fella here, brown, it's a bed resistor, body end dot. So the body is brown, the end is black. So 1, 0, and 4 zeros. So we've got 100,000, 100K, and 105K. Gee, wow, that's amazing. This one here, body end dot, red, 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 black. I can't see anything else on there. Maybe red, black, red, which would mean 2K, if I'm reading it correctly. And 257K. There must be a yellow dot underneath this fella. So I would say, probably, it says 257. I can see, am I reading it? No, I can only see red, red, black, and obviously yellow, which would be 200K with the dot underneath, but that I can't see. And we've got 220 and we've got 257. So I hope you guys saw that meter. I didn't realise it was turned around. 257. We're pretty close. Right. It's looking good. Now, what I'm going to do is, well, I think the best thing here is to jot down on some paper some connections here. I will then draw out some sort of schematic of how this thing's wired. We don't know yet. Quite interesting. And there's our selector. It's 2 pieces of wire. Push him into the hole you want. How's that? Don't know what that one is. I'm guessing this is how you select it. Yeah, some are a bit tighter than others. Now this red post here comes across here, and as I said, he comes over here. This appears to be a coarse voltage selector. This may have taken the place of a rheostat, or may have been this instead of the rheostat in the middle. Not sure. The rheostat probably would have done away with these resistors as well. This doesn't look like this been modified. I'll show you an image shortly on one that looks almost identical to this, and that knob was there back in the day, and the great big hole in the top of it was there. Okay, can't tell you as much more at the moment, so let's have a look at the valve, a BH. It's a Raytheon, Raytheon. It's a Raytheon type BH. Now, apparently these are a cold cathode rectifier, as I've said, and what does that mean? There is no cathode, or what? Is there a filament in this? I'm guessing there is. Possibly the big ones are the filament, maybe. No, nothing there. Maybe the small ones. Nothing there. Okay, I'm not real sure how these are supposed to work. Okay, a cold cathode rectifier. Okay, let's bring up a sheet, and we'll just have a look at what the sheet says. I mean, this is old. This is 1920s, so this is what they had. Well, there's a little bit of info, but yeah, I've never seen anything like this. And well, maybe some of you guys out there would know about those rectifiers. I'm sure there is. If you can give us any more info, or am I wrong with what I've read or researched, leave them in the comments below. Be very interesting to find out a little bit about what life was like back in the 1920s. Okay, let's get this thing out. This lamp. Yes, he's solid. Why or how does he come out? Doesn't want to twist, doesn't push. Yeah, doesn't pull. Might heat this with a heat gun, soften the plastic, and then we might be able to do something with it. So I'll do that, undo this fella, and I don't know, we might have to take this terminal block. Oh, no, I think it'll come out past it. We might have to take the screw. No, it can't. It's got to come out, hasn't it? Because our terminal block is these wires here. So we're going to have to mark these and undo them and take the terminal block off, and then try and get, well, obviously loosen our switch, try and get the thing out of there. Okay. There we go. Little bayonet one. Plastic softened up, so we've got him out. Now it's a matter of getting the holder out. This microphone's going to be the death of me. If you watch my videos, you'll know what I mean. Okay, there we go. So this must have been, don't know, bit of insulation or something. But yeah, actually goes in quite easy. So probably just to make it look pretty on the outside, I'd say. Right, that's that one off. This fella comes off pretty easy. And once we get, there we go. He's also got some red plastic over him. And obviously this is insulated from the case. Right, and there's our wire that goes to him. This will probably be a multi-part series too, guys, because I'm probably going to have to ask you guys some questions on this one. So, yeah, there's a lot of things I don't know about with this. So, there's, well, that wire. Now, I think what I'll do here is undo the two screws and nuts, and then we can work out where these wires go. There's one in underneath there. I think he comes across to here. I think that's him just there, and he runs across here under there. This one to there. So yeah, we'll buzz these out with a meter, but I'll take the screws out first. Okay, got this screw out, well, loose. A little plate been sitting in there to hold this side, well, in position or something. I think, hang on. This plate, this piece, comes off with this, but we still have to get the screws out because it's, yeah, these fellas go in and hold it to the case. Okay. Very strange arrangement. So we don't have to unsolder anything. Well, that's theory anyway. There we go. Nuts off. Yeah, there's our little plate. Holding him in. There we go. It's actually got a little lip on the bottom that must come in under here somehow. There we go. So now, yeah, everything is separate. This one just come off anyway. Okay. What an interesting arrangement. There's our pin, but not lose him. Where are they screwed in, or how are those wires held in? Nothing under there. There must be something in here behind this plate, or they're soldered in or something. But anyway, probably don't need to take any more there. So what I've got here, a red wire that, well, get rid of that. This red wire, all we need to do is get him inside the box, and then we'll chase him later. Okay, and our power cable, same thing. Now, I don't think we'll be using this plug again, nor do I think we'll be using this power cord. He's, yeah, already been patched up. So, you know what to do, guys? There. That's got rid of him. There's a little bit of spaghetti on him there. Okay, now we're up to our knob, which has an Allen key in there. Let me get that. We'll be back, and then we'll get him out, and then I think it's time to undo some screws in the bottom. Okay. He's loose. Grub screws right out. Must be a second screw, isn't it? And there is. How about that? Two grub screw knob. That's making sure it's going to stay on there. Okay. Here we go. Aluminium by the look of it. It'll clean up okay. As I said, I want to restore this thing. Now, it's not loose, that's for sure. Using my horrible little pliers to do this. That's a no-no. Okay. And now, can we move the switch back enough? Oh, there we go. It hasn't broken anything yet. Now, there's a fibre washer on this fella. Okay. Let's sort of got everything out of the road there. No other wires. There's nothing else external. Let's get the bottom off. It's what you guys have been waiting for, and myself. There was probably rubber on these feet at one stage. Otherwise, they'd certainly cut into a bench. Little bell type washers they are. Okay, here we go. Nothing's moving. Anything moving here? Ah, okay. Here we go. And we're catching on what? I'll tip him up this way. Ouch, my finger. There we go. Guys, there it is. Let's give you a real-time look. Okay. Did I say I was going to restore this? Okay. Capacitors. What's all this? Transformer, I guess. What's this? Oh my goodness. This has had work on it. There's some new solder work here. This seems to be new, actually. These capacitors appear to be fairly new. They're 8 microfarad, 525 volt peak. Let's go. That's what's in there. And that's very similar to the diagram I have as well, which I'll bring up shortly, as soon as we have a bit more of a look at this. Yes, okay. Okay, indeed. Some screws down here, which, what do they do? Those two hold our indicator neon, which we don't know where that goes yet. These two here hold an L bracket, which our capacitors are sitting on. Yeah. Now this would be the transformer, because here's our mains lead. Well, used to be connected to there and there. This would be the mains transformer. We also have high voltage, I'm guessing. Now we might have some sort of, I don't know what's happening here. Two wires here out of the transformer, a wire over here, which is pin number, yeah, no, it's not written there. Don't know. It goes to this transformer. Well, if this is a transformer, I don't know. I don't know whether these have been, this has been modified or this is part of it. The screws look fairly original. So switch, no broken resistors. So we'll, at least now we can sit down and draw the circuit out. That was over here. That one went outside. Yeah, okay. Before we go any further, this is obviously a transformer. Let's check continuity between those two terminals, because if that is open circuit, this transformer is open circuit, we've got no hope. Okay. There you go, you can see that. Yes, 130 ohms. Yep, that would be a transformer. Now, there's also two wires come out to the socket of our cold cathode rectifier, and we've got 630 ohms, possibly high voltage. It's this one, and this one is through capacitors or something. Yeah, not getting a reading on this one. Okay, guys, I'm going to now pause the video. I'm going to sit down and try and draw out what's happening here. Once we work out the top section here, we'll take it off, unsolder everything, take it off, so that we can test transformer and whatever's happening down here. Interesting. Now we've got the capacitors down in there. The wires come up here, go into here, into this thing. This could be a choke. This is probably a reactance choke or something along those lines. Can we see anything in there? Not really. Yeah, I would reckon this is a choke, transformer, capacitors, and yeah, we'll work this out. We'll get it going somehow. No way you can get in the back of it or anything. The back is actually spot welded on, and the back is the bottom as well. Yeah, it's probably a non-serviceable item. So it did happen back in the 1920s when you couldn't service things. I'm sure we'll do something with this. Yeah, the first test will be interesting. Getting a dim bulb on here. Wow. Yeah. Okay, I'll be back soon. Okay, well, so far I'm just drawing up a mud map on how this was wired up the top. Haven't gone into the circuit yet, but should be reasonably straightforward to draw up a circuit on this, I think. But anyway, I'll probably start drawing the circuit. I've got to unsolder this switch now and get the switch out of circuit and everything. I'll draw up the circuit of the switch, the three resistors, where they go to, put the circuit for the resistors in. Then I can start joining the dots with, with a bit of a circuit. And I hope I don't get in trouble for reverse engineering and doing my own circuit from YouTube, like Mended Mark did. So, yeah, we'll just keep going and, do the circuit. I'm certain it's not copyrighted, not from back then. But anyway, um, it's obviously a good piece of gear and it worked in its day. It will work again. So, yeah, we'll keep going, keep plugging along, just giving you an update of where I'm up to now. So, another sheet of paper and start the actual circuit. Right, well, we've got the switch off. And, well, the drawing is sort of all over the place at the moment. It's got to be tidied up, but I sort of know where things are. But this is not the transformers yet. We've got to work out where they join into the circuit. I can only find two of those four caps. These other two go in here somewhere. Now, probably either side of the choke. I don't know. But anyway, we'll keep tracing this. This is where we're up to. I'm just about to take the resistors off the top and get rid of this arrangement to just be able to diagnose what's in here a little bit better. Well, there it is. We're getting some parts off it. We've got to clean all this up. Power in. Now, obviously these two wires here go to our rectifier from the transformer. Now we've got one here that seems to come from the transformer, but then we've got 3 down here that come from whatever this is. Now I think this is rectified out here to a winding, and somehow these are the other end of the winding. All these go to the filter caps. Those 3, well, actually the 4 of them, there's another one up here, go to the filter caps. So we're just about finished drawing out the diagram of the damn thing. Here, this is this little plate that was up the top that everything was attached to. Now it's the word scribbled in here is, I'll try and get a bit closer. You've got low, and then you've got, well, I think it's M, and I'm pretty sure MID, mid, and max, and AC. The AC one comes from the transformer. So these are the different tappings from various points up the top. The resistors have been put on, so yeah, you'll see on the diagram when I'm finished up with it. These fellas, well, yeah, now I've got to trace what goes where with these fellas. This is obviously a choke? Is it a multi-tap choke transformer type thing? I'm not real sure. All I know is the rectifier, we've only got 3 leads. We've got that and that, which has got plus and minus on it, which is a little bit confusing. And we've got P, which sort of indicates maybe plate, but this rectifier sort of doesn't have a plate. So I'm not real sure. So now I'm going to go through, we've got to get this fella out, and there's a little nut in behind here that's a little bit hard to get to. Get this off so we can clean everything up. This is some sort of tar that's been put in here. Quite clean. It's not bad, but of course we can't really see what's in there without melting it out, and I'm not doing that. So we'll get the meter on these fellas and try and find out what's happening. If you've got any suggestions about this or a circuit, I do have a circuit that's very similar but not the same. Okay, so there it is. It's an Acme E3. Now, there's lots of other Acmes on Radio Museum. No E3s. I can't find an E3 anywhere. I think I've got an E6 or an E5. Different model, different thing altogether. It doesn't have resistors or anything like that. Okay, I'll try and work out what's what here, what happens here, and yeah, I'll come back with some resistances. We might hook power up and see can we get anything out of the transformer or work out something out of this. Okay, guys, well, we've stripped everything off it. Now, we're going to test the transformer, 240 on here, and, well, that's one end of our secondary, and the other leg we've traced through goes to our regulator. And we'll put the meter on the secondary and we'll see what's going to happen here. I really don't know whether this transformer is going to work or not. It's a pretty ordinary looking setup actually, but you'll see it live as it's happening. Okay, here we go. We might see smoke, flames, or voltage. One of them anyway. Okay, that's on. Righto. We'll turn the dim bulb on, but we've got the variac on 0. Okay, dim bulb is on. I certainly want this through the dim bulb. 2.2 volts. So something's going through there. Okay, here we go. Okay, whoa, okay, 46 volts. Now on 50 volts on the variac, 103 here. No smoke, no dim bulb. 110, we've got 253 on the secondary. 150 on the variac, 314 here on the secondary. 180 on the variac, 379 on the secondary, and as you can see, 6.3 volts. Our lamp's working. Okay, here we go. 200, 240, no smoke yet, no dim bulb. Okay. 500 volts, 503 volts across the secondary. So more or less across the rectifier, it'll be 250 a side sort of thing. So there we go. We've got a 500 volt output. It is drawing 3 watts, which is, I would say, very normal for this. 6.3 there. Well, that's a 6 volt lamp. So I'm guessing it looks correct. So I am assuming the 6.3 is okay. Guys, we've got a goer here. The transformer's okay, but that's only testing this transformer, not the choke assembly or anything that's in here. Now with the choke, we've measured the resistances and everything. Of course, no voltage goes to the choke because we haven't got the rectifier in. That's probably the next trick of putting the rectifier in and see if we've got any DC coming out of here. Okay, let's do it. Let's see how we go. I'll pause the video. I'll go and grab the rectifier and come back. 2 large ones, 2 large pins go to the back. Now, as I said, I know nothing about these. This is all new to me. There we go. He's in. Might bring you guys in a little bit closer on this one. See what happens here. Where do we put our negative line? We'll run from this one. We'll use this end as, yeah, I'm just trying to get this in my head. This end of the secondary, and connect onto, well, one of these to see if we can get any DC voltage out of this. We do have 88 volts DC coming here, so the rectifier appears to be working. Okay, 150, we've got 130 volts. 180 on the variac, we've got 156 volts. This is working, guys. This is DC. Okay, we're up to 200 on the variac. We've got 175 here. Of course, this is have to be lowered down because that's why we've got the resistor array and everything else. 220, 230, 230 volts there, which I'll leave it about that, and 200 volts DC. And it's really strange having this, a cold cathode rectifier tube with no filament. That's crazy. I've never seen one of these in action. But there we go. So we've got 200 there. 200, of course, they're all going to be 200 because there's no load on the choke at all. And do we see anything on the AC? Yeah, we've got 100 volts AC floating on this, and of course there's no caps on it, so you're going to have some pretty fair ripple there. But all that will settle down once we get the caps on it. Most importantly, 200 DC there, so this unit is working. This is good. Okay, guys, I'm going to cut this video now. I would love your comments on this. Does anyone got more information on these, especially a circuit of this particular unit? As I said, it is, I'll just move this out of the way there. It's, there it is. Okay, it's an E3 Acme. Says the input, doesn't say anything about the output. Okay, so I'd love to hear your comments. If you've got a circuit, yes, I've drawn up a bit of a circuit. I don't know whether this has been modified since it was built. There's certain things in here that makes it look like it may have been modified. Maybe the caps. There's a lot of soldering that, yeah, doesn't look right. I don't know whether these are probably original caps, these Ducons. I have no idea whether these are okay. We haven't tested them yet. So if I could find out a little bit more information on this, really appreciate it. Then we can go ahead and, yeah, just check everything else and start cleaning up, rewiring, getting it back together and using it on the bench. Okay, guys, if you like this, give us a thumbs up. If you want to follow me, hit the subscribe and the bell, and you'll be notified when the next one comes up. And a lot of people, strangely enough, have asked me, subscription, how much does it cost? Guys, subscription doesn't cost anything. You just follow that channel. That's all it means. So many people ask, and it's very odd. But yeah, the word subscription sort of is the first thing you think of is subscribing each month for an amount or something like that. But anyway, subscription's free. Go for it. Hit the bell, and I'll catch us very soon on the next one. Hopefully, a little bit more information on this one, and we'll getting back together. And the next project will be back on the Carl's National Radio. Better get the case ready for Carl on that one and get the radio in the case and yeah, finish up that one. Okay, guys, catch us next time. Bye for now.